The heart rate's response to steady-state exercise is that there will be an increase in heart rate. This is because the heart has to work harder in order to supply the working muscles with oxygen. The reason that this happens is because when the muscles are working, the chemoreceptors detect an increase in CO2 and decrease in O2. This information is sent to the cardiac control center in the medulla oblongata, which relays this information to the SA node, which causes the increase in heart rate. Here we can see that after minimal exercise for 2 minutes their heart rates had increased, and then by 8 minutes they had all increased quite drastically. With 2 clients, Summer and Max's heart rates had more than doubled. Then their heart rate started to plateau with some decrease and increase. We can also see here Josh's heart rate at the start of the exercise decrease instead of increasing. This could have been to having a slow start, or the data was just recorded wrong. This isn't the only part of data from Josh, as his heart rate before starting exercise is at 105, which isn't normal for someone. Summer's and Max's are very similar to the normative data, especially Summer. This is because at the start of the exercise for the normative data, their heart rates tend to increase steadily at the start, and then around halfway through the heart rate starts to plateau, and then once the exercise is being completed, their heart rate drops a bit lower than where it was during the exercise, but nowhere near to their original heart rate. This is what happened for Summer and Max, but not Josh, as he had a slower start and only managed to hit his top heart rate by 20 minutes. During steady-state exercise, the blood pressure response is that the systolic pressure will increase. However, the diastolic pressure won't change and might even lower slightly. During exercise, the heart needs to pump more blood through the blood vessels to supply the working muscles with oxygen, so therefore there is an increase in systolic pressure when the heart contracts as it forces more blood through the vessels. Here we can see in the systolic blood pressure graph that Summer and Max's data is very different. I know from the normative data for systolic blood pressure that it gradually over time increases, but not drastically, and doesn't decrease. As we can see here that this isn't the case for either Summer or Max. Summer's was similar, as it gradually increases until 14 minutes, where it starts to slowly decrease. Despite this, her blood pressure at the start and throughout the exercise isn't how it normally is, as hers starts at around 65, where it normally starts at around 130 and increases from there. However, Max's starts at 145, which is normal, but instead of increasing, it decreases quite drastically by 45 in 8 minutes. After this, in the next 2 minutes, his blood pressure increases by 80. This shows us that his blood pressure probably wasn't being recorded properly in the first 8 minutes, as it isn't normal for it to decrease and then to all of a sudden increase by so much, as it normally increases throughout gradually. During steady-state exercise from the normative data, the participants' O2 saturation should remain pretty constant throughout the exercise, with little change, with it staying around 98 with little increase. This increase in O2 can be a catalyst with pyruvate acid and is fed into the Krebs cycle, allowing for aerobic respiration to happen, meaning that we can work at an increased level of endurance as long as they keep the intensity at a steady state. Here we can see that they all started off at around 99 and remained pretty constant throughout the 20 minutes. Despite this, we can see that Max's data was different to this. We can see that around 12 minutes, Max's O2 saturation dropped by more than 10 and then went back to where it was after around 3 to 4 minutes. This is very abnormal to happen and may have happened due to how it was being recorded or the equipment that was being used to record the data. However, this did not happen for Summer or Josh, and their data shows us that it is very similar to the normative data, as it stays around 99 and was constant throughout the whole 20 minutes and pre and post 1 minute. When performing steady-state exercise from the normative data, the participant's blood lactate shouldn't increase too much due to it being an aerobic exercise and not much lactate acid should be produced. This will be due to the muscles not working as hard as they would when performing anaerobic exercise, as this isn't at such a high intensity, so then the working muscles aren't having such a high demand for oxygen due to not much lactate being produced. They should also start at zero before any exercise is started, which happened for them all. This should happen as they shouldn't have done any exercise beforehand, so therefore they wouldn't have produced any lactate in the muscles due to not exercising. This all happens for Josh like it should, but for Summer and Max, after 2 minutes, their blood lactate shoots up to 16 and 12. This will have been due to the fact that their muscles will have been working harder, so therefore their muscles will have produced much more lactate due to them working harder than steady state. This is normally what would happen for someone participating in anaerobic exercise, which suggests that at the start they could have been working too hard, which led to an increase in lactate acid that was produced. After the 2 minutes, Max's and Summer's blood lactate began to plateau, especially Max's after 10 minutes. Max's and Summer's blood lactate drops, but at 16 to 20 minutes, Max's carries on dropping all the way to the 2. But Summers increases again to 17. This isn't what happens in the normative data, as it is supposed to stay constant, with little increase during exercise in blood lactate. This may have happened for Summer due to her starting to work harder than needed towards the end of exercise, so therefore it wasn't the same as the normative data. This would have been the same for Max as well. The initial response for the respiratory system is the anticipatory rise. The way anticipatory rise works for the respiratory system is that it causes an increase in breathing rate prior to exercise. This happens due to a thought or feeling passing through the dorsal respiratory group to the intercostal nerve, then into the external intercostal muscles to contract to cause an increase in breathing rate. For example, if you were taking a penalty in football, your emotions would be running high. This is detected and then sent to the dorsal respiratory group, then to the intercostal nerve, into the external intercostal muscles, which contract to increase the depth and rate of breathing. The normative data for breathing rate during steady state exercise shows us that at the start of the race to the first few minutes, their breathing rate will increase, but then after around 4 minutes, it will start to slowly plateau. This is what happens for Max, but his breathing rate starts at a higher level than usual, which suggests that he was working at a higher level than required. Despite this, his breathing rate increases by 6 in 6 minutes, from 2 to 6 minutes, and then eventually plateaus, and then slowly decreases after 12 minutes, but only by 4, from 12 minutes to 20 minutes. We can see here with Summer's results that the slow increase happens at the start, like it usually would, but instead of plateauing after 8 minutes, there's a more of a sudden increase in her breathing rate by 5 and 4 minutes, and then from 12 to 16 minutes it drops again by 7 and then increases again. In the last 4 minutes by 3. So from this, we see that Summer's breathing rate never plateaus, which isn't what normally happens, and could have been caused due to her not going at a steady state pace, and going quicker and then slower at different times. On the other hand, Josh's data is very different, as at the start of the exercise up to 4 minutes there is an increase in his heart rate by 8 and then decreases by 4. After this, his breathing rate doesn't plateau, as it is always increasing, but very slowly, as it increases by 6 over the course of 12 minutes.